Well, I want to start today by telling you a story. So, I have an older brother named Sean. And when I was a kid, and by the way, Sean is 10 years older than I am. Not that that matters, but a little bit. See, because when you're 10 years older, you're also bigger. That means he was 150 pounds and I was only 80 pounds. And he was my hero, obviously. I wanted to be just like him, but everything was a competition with my brother. And it didn't really seem fair. One of the things we always competed about was who could eat the most ice cream. I'm serious, this was our competition we would do. And my brother would eat this ice cream cone that they used to make, and it was called the Bellyache. And they would put like 10 scoops of ice cream on this one cone. I mean, I couldn't eat 10 scoops of ice cream. That was impossible for me. But I could eat 5. And he would always say, ha, I win. But it didn't always seem fair, right? Like he's this big guy. He's got 70 pounds on me. And actually if you think about it, I think I might have won. So let's say for a second that each scoop of ice cream is exactly the same. If we were to be able to try to compare this, he ate 10 scoops and he was 150 pounds. And I ate 5 scoops. 5 scoops. And I was 80 pounds. It's interesting. These aren't exactly the same. In fact, they aren't the same. And the only way we could compare these is to, make them based on an equivalent weight or equivalent scoops. And this brings up an interesting idea of things being proportional. See, this is not proportional. Had I eaten, had I weighed half of what my brother weighed and ate half of what he ate, then it would have been proportional. But I weigh more, and actually, in fact, I ate more proportionally. And that's what we're talking about today. We're going to be talking about proportionality, and specifically how to write and solve proportions. So today we're starting on page 418, writing and solving proportions. So today I want to teach you first is that a proportion is an equation that states two ratios are equivalent. Two ratios are equivalent. So let's throw two ratios up there. Here we have 3/5 and 6/10. So in numbers, those are equivalent. I know they're equivalent because if I multiplied both 3 and 5 by 2, I would get 6/10. These are proportional. But proportions aren't necessarily all about equivalent fractions, although the math does kind of come down to it. You read them in a specific way. And here is how you read them. Let me write it out so you can see it at the same time. 3 is to 5 as 6 is to 10. So this is how you would say it if you looked at it. 3 is to 5, because it's a ratio, it has that word 2. 3 is to 5 as, this is my equal sign, as 6 is to 10. So it's kind of unique seeing them, but it's not that wild of a concept, and let's jump into it. So the first concept we're going to look at now is how to use equivalent ratios. Let me get my paper squared up here. So the example asks, well, first off, let's see. So when one of the numbers in the proportion is unknown, you can find the number by solving the proportion. And one way to solve a proportion is to use mental math to find an equivalent ratio. So the first example is, find the number C of calories the person discussed above would burn when inline skating for 60 minutes by solving the proportion Okay, so we're not going to read the example, but instead I just want to look at how you can solve it. So we have 210 is to 30 as C is to 60. Make sure that's in the picture here. Perfect, yeah. So here I have a proportion, but I don't know which one of these numbers is. One of my values is missing. I have a variable. So I have to ask myself, what number can I multiply 30 by to get 60? What number can I multiply 30 by to get 60? See, I can go this way, but I can't go this way, right? I mean, I don't know what I multiply 210 by to get C, but I do know this. I can multiply it by 2, and I get 60. And you got it. If I do it to the bottom, you do it to the top as well. So there it is. So let's see. If 30 times 60, or 30 times 2 is 60, 210 times 2 would be 420. So C equals 420. Not so bad. Okay, cool. So the second thing I can do, other than mental math, this is my mental math strategy, just kind of asking yourself, well, what can I multiply? The second thing you can do is everybody's favorite. You can use algebra. So the same method that you use to solve division equations in chapter 7, you can use them to solve proportions that have the variable in the numerator, when your variable is in the numerator. So take a look. So if I have 6 is to 10 as x is to 25, I know that if I can get rid of this, 25, I'll just have x by itself. Let me say that again. If I can get rid of this 25, I'll just have x by itself. So what if I multiply it by 25 times 25? Because 25 will end up being 25 over 1, and then this is going to be 25x over 25. And then these will end up turning into 1. You got it. And then I'm going to have just x, or 1x. But you don't have to do this the whole time. Instead, if you just multiply it by 25, you know it's going to get rid of those two. But remember, if you do it to one side, that's right, you have to do it to the other side. So here we go. So times 25 on both sides. And so when I'm looking at 25 on both sides, as I'm only multiplying it by the numerator, multiply each side by 25, I'm going to end up with 150 over 10. 150 over 10 is equal to x. Simplify, that's the division problem. 2 zeros cancel out. 150 divided by 10 is 15. X equals 15. So there's a couple problems we can do together to try to figure this out, because this is a complex topic, there's no doubt about it. So let's start by looking at a couple practice problems. So I'm going to do guided practice number 1 together. In number 1, it says use equivalent ratios to solve the proportion. And then I'm going to do number 5 together. And number 5 is using algebra to solve it. So let's do number 1 first. So number 1 says 1 is to 5 as z is to 20. So remember that mental math question I was trying to ask myself here, guys. Remember that. I have to say, what number can I multiply 5 by to get 20? And that number is, hopefully you got it, that number is, oh, I am not in the picture. Let me show it again here. What number can I multiply 5 by to get 20? That number is 4 times 4. So if I multiply by 4 on one side, I multiply by 4 on the other side, and then I'm going to get 4. Z equals 4. Yep. So 1 times 4, this is going to end up being 1 over 5. 1 is to 5 as 4 is to 20. So that's the first way, is using your mental math strategy. And this is a good way. It's a very useful way. Let's look at one more here. This is number 5. For number 5, I'm going to use my algebra strategy. So I have 4 is to 14 as m is to 49. Now, facing the same kind of struggle here, I'm going to have to get rid of this 49. Now, I know if I multiply, going back to that same strategy we looked at before, if you multiply each side by whatever your denominator is, here I did by 25, so I'm going to multiply it by 49 times 49. And I'll multiply this side by 49 as well. Remember, it's 49 over 1. So these two are going to end up canceling out, and I'm going to end up with m. But I'm going to have a pretty interesting situation over here. 49 times 4 is what? 98, and 98. And 98 is 196. And 196 divided by 14. Now we have to do some thinking. How many times can 14 go? Well, guess what? You get to use a calculator. And when you do your calculations, you end up with 14. M equals 14. So where these things kind of get challenging that I want to point out is this. Let's go back first to the mental math strategy. In this mental math strategy, and this works really well for a lot of people, you see a pattern between a relationship between 5 and 20. You say, oh, 5 times 4 is 20. So if I multiply 1 times 4, I'll end up getting z. These are proportional, so it has to be equivalent. And I got it, no problem. But it doesn't always work. Here you have 14 and 49. I couldn't have jumped. What do I do to 14 to get 49? I don't know. I can't. But I can use algebra to solve it. And so if I multiply both sides by 49, that will take out my denominator, and I'm left with 196 over 14. That's a division problem, and 14. Okay. Let's do one last problem. So in this last problem we're going to do together is, let's do problem number 8. I think the algebra problems are probably some of the most challenging. So we're going to do problem number 8. In problem number 8, you're going to see b is to 8 as 7 is to 28. So already I know I can't use mental math, because what can I do to 8 to get to 28? I can't do anything. But I know how to get rid of 8 as a denominator. I multiply it by 8. Multiply 8. And if I multiply by 8 on one side, I multiply by 8 on the other side. These two are going to cancel out, and I'm left with b. But now I have a pretty interesting situation. 7 times 8 is 56 over 28. But you know what? That's not the end of the world, is it? I can use my calculator, or I can just realize I can divide. So b equals 2. So there you have it. You know, it's kind of tricky for sure, but I think when it comes down to it, it's very, very doable. So next I want to talk about how you can set it up, like write and set up a proportion. And to do that, I'm actually going to put the book in here and get the book all centered, because they do a great example in the book on page 419. So let's take a look at page 419 here at the example for when it comes to setting up a proportion. So here we have it. So a proportion may be set up in several ways. So you can consider the following problems. Wednesday you bought 8 folders for $4. Today, you need to buy 5 more folders. How much will 5 folders cost? So remember, the price, let's just assume the price of folders has not changed, okay? So the information is arranged in the 2 tables below, is which X represents the cost of 5 folders. Either of the proportions that can follow from the table can be used to solve the problem. So you can do it both ways. So if the cost of the folders yesterday was $4 for 8 folders, today it's going to be 5 folders, and the cost is going to be proportional. It's going to be proportional. So there you go. That's how they set it up. 4 is to $8 as X is to 5. Sorry. $4 is to 8 folders as X dollars is to 5 folders. Okay, here's another way to do it. You can also say that in the second round, they just changed how they organized it, and they have yesterday and today as our x-axis. And you can say you bought 5 folders, 5 is to 8 as X is to 4. So you can use either ratio to write a proportion. It's pretty straightforward. And then from there, you could use algebra to solve them. Or perhaps you could even use mental math to solve them. So on the next page, what you'll see is some examples of how to write and solve a proportion. And so I'm actually not going to show the page. You can follow along on page 420 if you'd like. On page 420, you can see an example. So let's read it together and take a look at how to write and solve a proportion. So the elevators in the Empire State Building can pass 80 floors in 45 seconds. Follow the steps below to find the number of floors that the elevators can pass in 9 seconds. So first, let's write a proportion. We're going to let X represent the number of floors passed in 9 seconds. So I know that 80 is to 45 because it goes 80 floors in 45 seconds. And the speed of the elevator doesn't change as you go up or down, or if you're going less. It's always just we're going to assume it's the same. Now, I don't know how many floors I'm going to go, but I want to know how many can I go in 9 seconds. And so we use a variable to represent the floors. Let's just call it X floors. So I can solve it in lots of different ways. See, here's my original. I'm just going to rewrite it just using numbers here. So 80 is to 45 as X is to 9. And I know that that's one of the most challenging things is remembering how to say it. So that's why I keep saying it that way. So, I'm thinking about what could I do? I'm just going to use algebra. I think algebra is the best for me. So I'm just going to multiply by 9 on both sides times 9. That's going to get rid of those 2. And then multiply this side by 9 as well. So I'm going to end up with 9 times 80 is 720 over 45 is equal to X, because remember, the 9s cancel each other out. So 720 divided by 45, actually you can do that division in your head or calculator, but it actually equals 16. So X equals 16. So let's go back and see if that actually kind of makes sense proportionally in our head. If you can go 80 floors in an elevator on the Empire State Building in 45 seconds, can you go 16 floors in 9 seconds? Yeah, that seems about right. That seems proportional, and that's exactly it. So there's a couple more guided practice questions out there I'd like you to do. I already solved guided practice question 1, 5, and 8 on page 419. I'd like you to try out numbers 2, 3, 4, 5, 6, and 7. And if you're struggling with them, I will also be working through them at 8:45 on a Zoom, which you can come and join me. And then there's one more guided practice on page 420, and that is number 9. That is one in which you have to write and solve the proportion yourself. So yeah, again, just today a review. Today we learned all about writing and solving proportions. And we learned that a proportion is an equation that states that two ratios are equivalent. You read it as this is to this, as this is to this, and you can solve it two ways. You can solve it using mental math, and you can solve it using, where's my mental math paper? You can solve it using mental math, or you can solve it using algebra, both ways. Okay guys, dive in. I wish you the best, and I'll be on Zoom at 8:45 if you need any help. Thanks.